What enigmas does Titan harbor? With a diameter of 3,200 miles 0 or 149.5 km, Titan is the largest natural satellite of Saturn and is even larger than Mercury. It is the only satellite with a sizable atmosphere and the only body other than Earth where there is unmistakable surface evidence of stable liquid bodies. What more mystery does this fantastic satellite conceal? Does it have the right conditions to support life from other planets? Let's begin. On March 25, 1655, the eminent Dutch astronomer Christian Huygens made the discovery of Titan, which would later come to be known as the largest of Saturn's satellites. Titan is 40% more massive than Mercury, despite being bigger in volume. This means that despite being bigger than Mercury, Titan is lighter because Mercury has a massive metallic core while Titan is made up of lightweight materials like rocks and ice. Titan has a diameter that is 50% larger than the Moon and is 80% more massive than Mercury. Since Titan has a low density and a gravitational attraction of only 1.35 meters per square second, an object weighing 1 kilogram on Earth would only weigh 140 grams on Titan. As a result, a normal person on Titan's surface could lift heavy objects with almost any effort. The information we have on Titan suggests that its atmosphere may be mostly nitrogen, with up to 6% of methane and other complicated hydrocarbon molecules. The weather is mostly determined by seasonal patterns, just like on Earth, and the climate, including wind and rain, produces land-like features like dunes, rivers, lakes, and seas of liquid methane and ethane. Titan's methane cycle is compared to Earth's water cycle, however at a much lower temperature because of its liquids, both surface and subterranean, and strong nitrogen atmosphere. Titan's water data from NASA's Cassini mission on June 28, 2012, suggested that Saturn's moon Titan might contain a layer of liquid water beneath its ice crust. Scientists made this discovery by observing Titan's tides. Titan is distorted and stretched as it orbits Saturn due to the planet's strong gravity. If Titan were made solely of hard rocks, Saturn's gravitational attraction would have to result in bulges on the Moon that are only 3 feet, 1 meter, high, or solid tides. The analysis reveals that Saturn instead produces solid tides that are around 30 feet, 10 meters, high. This shows that rocky solid material is not Titan's exclusive constituent. First, scientists weren't confident that Cassini could see the bulges brought on by Saturn's gravitational pull on Titan. Nevertheless, Cassini was successful and measured Titan's gravitational field during the course of 6 close flybys between February 27, 2006 and February 18, 2011. Titan's tide size was determined using these gravity measurements, which NASA's Deep Space Network, DSN, assisted with. The observed tides cannot be produced by a large or deep ocean layer. Titan would be able to develop the bulges and compress as it orbits Saturn if there were a liquid layer sandwiched between the flexible outer crust and a solid mantle. The majority of Titan's surface is made up of water ice, which is abundant on the moons in the outer solar system, hence scientists predict that Titan's ocean will primarily be made up of liquid water. On Earth, tides are caused by the gravitational attraction of the Moon and Sun on the surface of our oceans. In the open oceans, they can grow to a height of 2 feet, 60 centimeters. Additionally, the gravitational force of the Sun and Moon causes the Earth's crust to bulge, resulting in solid tides of around 20 inches, 50 centimeters. But let's not get too enthusiastic. Experts say that a subsurface layer of liquid water on Titan is not a sign of life. These measurements cannot differentiate between the composition of the ocean floor made of rock or ice because researchers think that life is more likely to develop when liquid water comes into contact with rock. A spacecraft with planet-like atmosphere, the only naturally occurring satellite with a dense atmosphere, is Titan. Josep Comazai Sola, a Spanish astronomer, was the first to hypothesize that Titan might have an atmosphere in 1907 as a result of the edge darkening phenomenon. In 1944, Gerard P. Kuiper used spectra obtained from telescopes mounted on high-altitude aircraft to prove the existence of a considerable atmosphere. Titan's atmosphere is 1.19 times denser than Earth's, as demonstrated by the Voyager 1 spacecraft in 1981. Additionally, we must keep in mind that Titan has a weak gravitational pull due to its low mass, which allows its atmosphere to spread much farther than that of the Earth. For instance, the Earth's mesosphere's limit is about 120 kilometers high, while Titan's mesosphere's limit is more than 600 kilometers high. Due to friction and resistance from Titan's atmosphere, the Cassini space probe had to alter its route when it passed close to 1,000 kilometers above the planet. As the only nitrogen-rich atmosphere in the solar system besides our planet, Titan's atmosphere is rich in heavy gases and contains 94% nitrogen. The remaining remnants of other hydrocarbons, such as methane, ethane, or acetylene, are present in small amounts. Titan's atmosphere is assumed to be so thick because of interactions involving methane and ultraviolet light from the sun that result in a thick orange haze, which is thought to generate these hydrocarbons in Titan's upper atmosphere. It is impossible to immediately see through it. This reminds me of Venus because Venus likewise has a dense atmosphere that prevents us from seeing through it. Titan and Venus both have spinning atmospheres, which means that the atmospheres rotate considerably more quickly than the planets do. This is another similarity between the two planets. As each pole has a vortex that rotates every 9 hours while the satellite rotates every 16 days, astronomers noted this when they surveyed its poles. Titan is one of the most violent atmospheres in the solar system as a result, with winds that can reach 1,200 kilometers per hour. Because of these strong winds, it would be challenging to build a base on Titan's surface. Titan is a world that is incredibly rich in organic substances, particularly methane. This moon likely has a liquid hydrocarbon content that is hundreds of times greater than all of the oil and natural gas reserves on Earth in the form of oceans and lakes. The organic matter in its dunes may be hundreds of times higher than the total amount of coal on Earth. Methane on Titan acts as the oceans, rivers, and lakes off the land and creates clouds in Titan's atmosphere. When it condenses, it creates clouds that release particles of methane rain, which run through the rivers and channels of the satellite until they reach the lakes and seas of methane. As the only planet outside of Earth with a cycle that is exactly like that of water, Titan is the location in the solar system that is most like Earth. Prior to Cassini's arrival, radar scans from Earth and those from the Hubble Space Telescope had cut through the thick cloud and revealed Titan's surface to be heterogeneous. Moreover, it was unknown whether the lakes were a component of the irregular orography that was thought to be caused by low air temperatures that may transform methane into raindrops since the Voyager missions. At Titan's South Pole, a black area of around 15,000 square kilometers that resembled the footprint was discovered in the middle of 2005. Radar images of the smooth portions appeared hidden, leading some to speculate that it might be Titan's first lake candidate. A spectroscopic analysis published later in 2008 confirmed that it was a liquid surface made up of ethane and, possibly, methane, nitrogen, and other hydrocarbons. This discovery marked a significant turning point in astronomy because it was the first stable liquid reservoir discovered outside of Earth. A lake that, as it was later discovered, has a surface that is remarkably smooth, with maximum height fluctuations of 3 millimeters, almost mirror-like. On July 21, 2006, the Cassini probe's radar equipment acquired two black spots that resembled terrestrial lakes and measured 420 by 150 and 475 by 150 kilometers. The spots are located in Titan's North Pole, which is where the satellite experiences its coldest temperatures. A 27-degree tilt on Titan's axis causes it to have colder seasons and other warmer regions, just like on Earth. The presence of liquid on the surface was confirmed on July 8, 2009, when the Cassini probe captured a specular reflection over the North Pole of the satellite. Lake Ligeia Mare and Lake Kraken are the two biggest lakes on Titan. In 126,000 square kilometers, Ligeia Mare is larger than Lake Superior in North America and is situated at the North Pole. The largest lake is the Kraken Lake, which has a depth of more than 300 meters, a maximum length of 1,170 kilometers, and a surface area of 500,000 square kilometers, an area larger than the Caspian Sea. Due of their size, scientists refer to these lakes as seas rather than lakes. Titanic life unique to our solar system is Titan. This moon is a frozen time capsule that preserves the circumstances that prevailed on Earth in its earliest days. It is littered with lakes and dunes and covered in a dense atmosphere of nitrogen and methane. Titan is the only body in the solar system, aside from Earth, that possesses liquid on its surface and, thus, circumstances to mix the amino acids required to produce proteins, which in turn give rise to living things, even though the liquid on Titan's surface is methane rather than water. However, the evidence is not strong enough at this time. The Huygens probe safely landed on Titan's surface in the Adiri area on January 14, 2005, and took pictures both during its fall and while it was there. During the descent, a panoramic view reveals mild slopes with drainage ditches. The canals appear to go to a close-by, broad, level, and gloomy area. In a hazy setting, it even looks to depict a shoreline, islands, and what appears to be a sea of methane. The photograph acquired after landing depicts a level terrain covered in stones in the shape of rounded pebbles. They could be formed largely of water ice. According to ESA experts, the probe may have dropped on Titan's dark area. Keep in mind that Titan's surface is covered in frozen water rather than liquid water. There is currently a project called Dragonfly, which consists of a NASA space exploration probe that will send a shuttle with a robotic drone to Titan to study prebiotic chemistry and planetary habitability, performing flights with vertical takeoffs and landings in different parts of the satellite. Despite the probes and the efforts that have been made to study this satellite, we lack much data that helps us reveal the secrets of its atmosphere. Would you like a movie detailing this exciting mission to be created? Comment below with your thoughts and let us know. Furthermore, don't forget to press the notification button.